Hello there and welcome to our next video. In this video we'll be continuing to talk about the if statement and the else if and the else. In order to do so, I'm going to use a topic from math class, and I'm sure all of you at this point are familiar with the quadratic formula, negative b plus or minus square root of b squared minus 4ac divided by 2a. So we will be recreating that in our program. It's a little bit more complicated formula than many of the things we're doing or have done with the like area of a square and things like that. So we'll ramp our game up a little bit there. And then we're also going to use the if statement to talk about what's called the discriminant. The discriminant is the part of the quadratic formula that's underneath the square root. So when you pull that out, it's the b squared minus 4ac. You have three different outcomes. Of course, you can't do the square root of a negative number. So when this value is negative, bad things happen. I'm not going to go too far in depth with it because I know all of you are at various levels in your math class, but at least all of you know that taking the square root of a negative number is a very bad thing. When it's equal to 0, and then when it's positive, those are three different outcomes. So we're going to use an if, and else in order to code this. And to show you graphically what this looks like, of course, ax squared bx plus c, that's a quadratic. Hence the quadratic equation. Quadratics, when you graph them, those are parabolas. And so if I look at this little diagram, you have three different types of parabolas here. They're, of course, all the same shape, but talking about the roots, talking about the different x-intercepts, when that value, the discriminant, b squared minus 4ac, when that is positive, negative, 0, positive, you get these three different graphs. I was thinking positive because it's above the x-axis, or yeah, whatever. Anyway, when it's equal to 0, it lands right smack dab on the x-axis. When it's positive, it's going to hit twice. X squared tells you that there's two potential x-intercepts. So here you have 2, here you have a repeated root, and this one won't touch it at all. It won't cross the x-axis at all. It's going to have, again, depending on what level math class you're in, it's going to have two complex roots. None of that really truly matters for our program, of course. What I care about are the fact that we have these three different outcomes. And so we're going to code the quadratic formula, and then we're going to code the different outcomes. So if you want to open up Python with me, please, we will dig right in. So quadratic formula and discriminant, whatever period you're in, whatever date you're doing this, and then your name, or my name in this case. We're going to need from math import star. That's, of course, because we're doing square root, we're going to use that. And so we're going to do the inputs. We're going to do A, B, and C. So we're going to do A is a float input. Enter A. B, float input, enter B. C, float input, enter C. All right, so first, before we get into the if statements, let's actually calculate the two potential roots. I'll tell you how to do the plus minus. Plus minus is not a thing. There's no symbol for plus minus. You have to code it to separate things. You have 1 plus, 1 minus. So, hence, I'm going to make two variables because you have two different outcomes potentially here. I'm going to say x1 for the potential x-intercept, first one, is negative b. And to do a negative b, you just put a negative sign in front of it. Plus or minus. So for this one, we'll do plus. The square root, so sqrt of b squared minus 4ac. Now remember, you have to put 4ac with multiply signs. You can't just put 4ac. And then you're going to divide that by 2a, and one of the big mistakes people often make with this program is an issue with unit of operations. The quadratic formula, it's negative b plus minus everything else underneath the square root. The whole thing, the whole numerator is over top of the denominator. So because of the order of operations, if we do what we wrote here, it would do this divided, and it would be this negative b separately. So I'm going to put that entire numerator in a large quantity, and then just to be on the safe side, I'm going to put that in a quantity as well. That's really not going to make a difference, but I'm just going to do it just because. And so the easiest way to do this then, copy and paste. And you're going to make two quick changes. You have x2, and then change it to minus, because it's the same format, just one's plus, one's minus. You have x1, x2. So let's look at the different outcomes. We'll print x1 is equal to, and then I'll put comma x1, print, quote, x2 is equal to, comma x2. All right, now, for this, let's talk about the different numbers we can put in, because you can't just put in any old numbers to test this. I mean, these are actual mathematical things. So, going back up top here just real fast, I would imagine all of you have done some factoring at some point. So let's talk about some of the different potential outcomes. If you have something like x squared plus 5x plus 6, let's say, and then you're going to factor that, the factors, you'd have x plus 2, x plus 3. And if you don't know why that's the case, talk to your math teacher. You must have lost that somewhere along the way. You have x squared is the x times x term when you distribute. 2x, 3x added together gives you 5x. 2 times 3 gives you 6. So those are the two different factors, which means that the x1 and x2 are going to be, when you set each of those equal to 0, -2 and -3. Because x plus 2 equals 0, you move the 2 to the other side. Do the same thing with the x plus 3. Again, if all of this seems like, oh my gosh, where's this coming from? It's all math. I mean, all of you have passed Algebra 1 at this point, so should be good. So here's what I'm getting at. If we put in 1 for A, 5 for B, 6 for C, it should give us -2 and -3. Let's test it out. Quadratic. All right, so 1, 5, 6. -2 and -3, as expected. So that's great. What happens, though, when things go poorly? So, for example, let me run this again. And let me type in, let's say, 1, 2, 3. You get this. Math domain error. The reason you get a math domain error is because if you do the quick math down here, b squared, 2 squared is 4. 4 minus 4 times 1 times 3, 4 times 1 times 3 is 12. So you get 4 minus 12, which is a negative number. You can't take the square root of a negative number. The computer gives you an error just the same as your calculator would. So this outcome would be a negative discriminant, whereas the numbers I have up here would be a positive. And so let me just do that example that I just typed in. If I do 1, 2, and 3, it doesn't easily factor, and it doesn't factor at all. But the quadratic formula will fail because you get, a negative discriminant. And so I want to prevent the outcome of it crashing. And so what I'll do is I'll prevent the computer from doing that if in fact I have a negative discriminant, if I have a negative under the square root. So going back through, I have A, B, C. That's not going to change. I still need the input before I do anything else. But now, I'm going to say the D, discriminant, or, discrim, whatever you want to type in for your variable. I'll just type discrim just so it's a little bit more complicated than just D. B squared minus 4 times A times C. And so calculate the value. Now, I have some if statements. If the discriminant is less than 0, then I don't want to do the other stuff. I want to say print negative discriminant complex roots. And again, if you haven't done complex numbers yet, that's fine. But that'll be the end of that part. I'm not going to go on to do these other ones. What I want to do instead is say, oh, well, if the discriminant is less than 0, don't do this stuff. And now I can do elif. In other words, else if the discriminant is positive. Then I can do this stuff right here, tabbed in. And so all 4 of these lines of code, because they're tabbed in, are now underneath this. And so if the discriminant's negative, it'll only do that line of code, whereas if it is positive, it'll do all of this. Now the other outcome would be if it's equal to 0, which, I mean, the thing is, you only have in that case one answer. It's going to be a duplicated answer. So really, like, I could just do greater than or equal to. It'll just say x1 is equal to, do like 4 and 4 or something like that. So, to give an answer that would be a repeated root, I'll work a little bit backwards. Let's say I have something like, let's just keep it simple. X minus 2 times x minus 2. So it's a duplicated root, it's a double root. If you multiply that out, if you distribute it out, you'll get x squared. 2x and 2x together is negative 4x plus 4. So in this case, my a would be 1, b is negative 4, c is 4. And so when I do that, I want to get x equals 2, but I only want to print it once, right? So I have elif for all of that stuff, and I can just kind of squeeze it together with no vertical lines spacing there, and then I can do else. So with else, I can just take one of those and just get rid of the x1, just keep it as x, and you can do something like this. You can say print, there's something, double root, x is equal to, and then x. So you have if elif else. We do have basically the same problem, but this is a little bit more specific. So we have less than 0, greater than 0, and that else, which of course the only other outcome there is equal to 0. So let's try it. And again, remember that I'm using 1, negative 4, and 4 as my answers. So that should give us the final outcome, 1, negative 4, and 4. Double root x is equal to 2. And, one more time, let me just test it to make sure it doesn't do the negatives. The 1, 2, 3 outcome, you'll say negative discriminant complex roots. So neat little program, lots of overlap obviously with math class. You also have some of your more complicated math functions from the from math library, and then you also have another use of the if, and else. So thanks for watching. See you again soon.